So right triangle, a triangle that has one angle measuring 90 degrees, comma, denoted by, right? So you could have a triangle like this. If you have that little box, right, you know that it is a right triangle. Okay, so whenever you see that, you know that it is a right triangle. Hypotenuse, the longest side of a right triangle, always across the 90-degree angle. So we can actually do this again. Right? This would be your hypotenuse. So when you know where the 90 is, you just move across hypotenuse, right? Sum of a triangle is always equal to 180 degrees. What does that mean? The sum, the addition, right? The total number of degrees of all angles in a triangle is always 180 degrees. This means that if you know two angles, comma, you can find the third. By subtracting them from 180. So let's say you have one of these. I give you that that's 30. They're telling you that that's 90. What's that angle right there? Okay. So the question mark is usually just 180 minus the 90, which is 90, right? Minus the 30. Next line is question mark is going to be 60 degrees. Theta is usually like a symbol like this. Okay. Is simply a Greek letter used to label angles. It's basically a zero with a little across. So I go all around and then I just cut through it on my second way. So oftentimes a question will have like a theta like that. They're asking for that angle right there. So don't be scared if they do that to you. Okay. Isosceles triangle. A triangle with two equal sides and two equal angles. So make sure you write this down, okay? And how do you know a triangle is isosceles, okay? Well, for one, if you look at the side measures and they measure the same, you know it's isosceles. Obviously, that should be very obvious, but we use markings, okay? So if you, for example, see one of these, and they tell you that this is 90, and I would use a different color for this. You don't have to, but if they make markings like that across the side lengths, they're indicating that these two sides are the same. They measure the same. Okay? If you have that, you also know that the angles across from them are also going to be the same. Okay? So the two side lengths, you go across, then you know that these two angles are going to be the same. Okay, so it's kind of a neat thing. They could also have a triangle, a right triangle that looks like this, 90 there. They could tell you that these two sides are the same. Right? Then you go across from this side, you kind of find the angle that is across from it because every side has its angle. Okay, so you go across, so this angle right here would be the same as the angle over here. Okay. So far it should be pretty straightforward. And this is continuing for isosceles here. Sorry. I'm trying to think how I'm going to unknown. Oops. Unknown angles and then isosceles triangle. Case 1. When you have something like this. They tell you that these two sides are the same, and they're asking you for this angle right here. So let's say you have a triangle and you see these markings right away, you should be thinking isosceles because two are the same. Okay, how would you find this? Well, technically, if these two sides are the same, then the angles across these sides are also exactly the same. So to find the missing angle, in this particular case, you actually only need to know one of the angles to find the other two because they're exactly the same. So you would go theta, which remember is just a letter used for angles, is going to be 180 degrees minus, in this case, 90, and that answer is going to be divided by 2. Make sure, I will do this, make sure you write down brackets. What that means is if your calculator has brackets, use brackets. If your calculator does not have brackets, that means that you need to go 180 minus 90, hit equal, then divide it by 2. Okay, so that would be 90 divided by 2, which is 45 degrees. So you know that this is 45. You also know, though, that this is 45. Okay, and to get all three, add up to 180. Case 2 is when I will make it look different now. And let's say this is 50. This is not going to be a right triangle. And they're asking you to find that angle up there. So let's say they have these markings, you right away, oh, isosceles. So that means that the angles across from them are the same. They've only given you this 50 here, right? What do we know about this angle here? We know that it also has to be 50 because when the side lengths are the same, the angles across of them are the same as well. So just because of that, you knew that this is 50. So how would you find theta? Theta is simply 180 minus 2 times 50. Right? Or you can go 180 minus 50 if you'd like. So theta is 80 degrees. This is not a right triangle, by the way, because this should have been 90, but it is 80. So we can say that it is a right triangle. But these are the two cases for isosceles. It's very, I'm not going to deal a whole lot with isosceles, but it does come up. Okay? I think we are good. We're good to dive in. Yeah. Okay. So enough of terms and definitions. The Pythagorean Theorem. That's what we're going to focus on today. And I know it might be review for some of you, but it's very important to have this down and to be proficient at it. Okay? What does it do? Okay? First of all, only works with right triangles. That's very important because in grade 12, you'll learn how to work with oblique triangles, which is the opposite of right. Everything that isn't right is an oblique. Okay? Allows us to determine, oops, determine unknown side lengths if two sides are known. Okay. Also used to check if a triangle is in fact a right triangle. So we mostly use it to solve for side lengths, but we can also use it to check if a triangle is in fact a right triangle, and I will show you that. So this is, I guess, the biggest. It only works with right triangles. Allows it to determine unknown side lengths if two sides are known. That's the biggest one. That's what you've been using it most of the time. It also is used to check if a triangle is in fact a right triangle. Okay. So here it is. Given triangle ABC, and when you do that ABC, it's just the corners. So draw a right triangle like this. We will make sure C is here. A and B, it doesn't matter to me. If you want to put A up here, B up there, that's completely fine. We'll make a note here. Capitals denote corners or angles, right? Lowercase is equal to sides. This I forgot to mention earlier, but I think I did this at the beginning of the year when we were reviewing. So if this is called triangle ABC, across from C, this side length here is going to be lowercase c normally. Across from angle B is called lowercase b, and across from capital A is lowercase a. Okay. Notice that there's a right triangle. You're guaranteed it's a right triangle. We know that c squared, side c squared, is going to be equal to a squared plus b squared. I know some teachers have been doing ABC with you. They flip this on you, but I like to have it this way, okay? So the hypotenuse squared is equal to, these two here are called legs, okay? So the hypotenuse squared is equal to both legs squared and added up, okay? That's very important to remember. And a variation of this formula is going to be, watch this. If you want to know A, you would have A squared like this is equal to, you take C squared and you subtract the other leg from it. Your hypotenuse is here now. And then you have also that B squared is equal to C squared minus A squared. use if hypotenuse unknown. What am I doing here? Unknown there. And these two use if leg is unknown. Okay. And I think what I want to highlight here is that you're adding here, but here you're subtracting. Right? You're subtracting from C here, whereas here you're adding those two. So these should probably be on your study sheet together with the triangle, right? And what is important is, listen carefully, it is very important that you know where your hypotenuse is. So we label that C normally. A and B, it doesn't matter where you were to put these angles or the sides. It doesn't matter as long as C is there and across from it is the hypotenuse, okay? Very important. It is the longest side, no question about it, okay? All right, so now we're going to do examples. Okay. Pythagoras continued. Okay. Case 1, hypotenuse unknown. I'm going to split it here. So let's just start with the way you're used to it. And we have our 90 here. We'll say that this is 3.2 and this is 4.7. And let's call inches. Let's go with inches. So we will automatically call this C because that's our hypotenuse, right? And knowing that, oh, I'm missing my hypotenuse, I'm going to use this format of it, right? This one right here, where I'm going to have to add the legs together. So what you do here is you go C squared is equal to A squared plus B squared. Which one is A, which one is B? It doesn't matter. Let's just call it A and B like that. So C squared is going to be equal to 3.2 squared plus 4.7 squared. Then you go C squared is equal to, let's figure out what this is. So I need everybody to make sure they know how to type this into their calculators. So 3.2 squared is not 3.2 times 2, okay? Quite often students make that mistake. It's 3.2 times 3.2, like you're multiplying it by itself. So it's 3.2. My calculator has an x2 button. So I can just square it like that. It's slightly smaller than the rest. Plus 4.7 squared. And that gives me 32.33. Okay. The last step is, watch this. C, I want C, I don't want C squared. I need to take the square root of 3233. And I will make it a little shorter, you will see. So take the square root, find the square root button. Looks like that. and you might have to type in 32.33, or I can just press equal. It will take the previous answer. So this, we will do 2 decimals, so that's 5.69. The 8 gets bumped to a 9. And we are in inches, right? And there you have it. I will give you the shorter version now, okay? I don't want that many lines for Pythagorean theorem. Here's another example. Write that down. And you know how I always called it C, right? You can call it whatever you want. If you want to call this X, as long as you know that this is a hypotenuse, you will know that, right? X squared is gonna be 21.5 squared plus 42.8. Everything is squared in Pythagorean theorem. That's for sure. And watch this next step. X is equal to square root. So you basically figure out what this is and just write it under the square root. I want that step, this step, and then your final answer next. So let's go ahead and type that in, 21.5 squared plus 42.8 squared. So remember, you might have some scary numbers. It shouldn't scare you. You have a calculator. 2294.09. Take the square root of that. That's 4789. And that's feet. Oh, sorry. I don't know my rounding apparently, right? The 9 gets bumped to a 10, which bumps the 8 to a 9. So this is actually 90. This is 90. Okay. Notice always the longest, right? Comma, which should be reasonable. Students often forget to square root. So like they actually say, hey, the answer is 2294.09. It's way too big considering everything else, right? So don't forget that part. All right, case 2. Leg is unknown. So let's write down an example. So later on, just so you know, these will be word problems, right? A ladder is leaning against, and so forth. But for now, we're just going to keep it simple, okay? So let's say this is 9.14 centimeters, and this is 3.28 centimeters, and obviously there's an unknown side. We know that this is the hypotenuse, this is leg, and this is leg. You're missing a leg here. You can call it whatever you want. You want to call it X, A, B, it doesn't matter. I'm going to call this X, okay? I'm missing this side and it's a leg, so you're going to go X squared. It's always squared, remember. You take the longest side which is the hypotenuse, and you subtract the other leg from it, but always squaring everything. And your next line should be x is equal to this, right? So you go 9.14 squared minus 3.28 squared. You get 72.7812. Do not round. Write everything down. 7812. And then take the square root of that, and that's 8.53 feet. Oh, sorry, centimeters. Okay. So the important thing is to identify where your hypotenuse is, and then you go from there. One more. Um, 3.5. We'll do meters. This is 7.75 meters. This is a leg. This is the hypotenuse. So this must be a leg. Let's call this y. Okay. So we're missing a leg. You know you're going to have to do hypotenuse squared minus the other leg squared. You should at least. So the first line is to square everything. And it does matter which one comes first. Always the hypotenuse minus the shorter or the other leg. Y is going to be square root of whatever this is. That's 47.8125. And if there are more decimals, include them all. That's 6.91 meters. Check. It's shorter than the hypotenuse. It's within reason, so it does make sense. Okay. Okay. That's it for now. So if you're at home, go ahead. If you're at home, I want you to use the following worksheet. I thought I had it ready here to work on. Okay, so this worksheet goes with this lesson. Right now, don't worry about the top part here. So I'm going to zoom out a bit. Don't worry about this top part. You start at 7. Okay, 7 on all the way to the end. And the best part about this worksheet is that it has the key at the end. So the key, right, it has all the answers at the end, so you can double check right away whether or not you're on the right track. Okay, so get this handout. It says Pythagorean Theorem at the top. It's CUDA software, right? Pythagorean Theorem, skip the first part and then start right at 7. And that's what we're going to be doing today. And then tomorrow I'll talk about this a little bit more, about the top part, and that'll be it. All right.